Hello students, I hope that you are good, well and fine. In today's session, we will be seeing a new chapter, sequences and series. So as we move forward in this session, you will know about what do we mean by sequence and what do we mean by series and all the other important terms you will get to know. Clear? Okay. So I hope that it is clear. Okay. Now, let's directly jump to the main topic, which is the sequences. So, let's understand by using some examples what do we mean by sequences, or how do we get the idea of sequences, and in practical life, where are they? Okay, so assume that there is a generation gap of 30 years. We are asked to find the numbers of ancestors. Okay, that is parents, grandparents, great grandparents, etc., that a person might have over 300 years. Okay, here the total number of generations will be what? 300 divided by 30. Why? Because a single generation gap is of 30 years. Every 30 years there is another generation. Okay, so in over the span of 300 years, you will have 10 generations. Yes. Okay. The number of persons, ancestors for the first, second, third, and 10th generations are 2, 4, 8, 16, 32. And the last one will be 1024. These numbers form what we call a sequence. Okay. These numbers form what we call a sequence. Okay. So sequence is just nothing but what can you call is numbers, upcoming of numbers at first position, then second, then third, then fourth, and so on. Okay, I hope now you have a little bit idea that what do we mean by sequences. Okay, upcoming of numbers, okay, or one and after another. Okay, you will call such number form as a sequence. Now consider the successive quotients that we obtain in the division of 10 by 3 at different steps of division. In this process we get 3, okay, then 3.3, and then 3.33, and then 3.333, and so on. Yes, these quotients also form a sequence. As you can see, the first at first position you have 3, at second you have 3.3, at third you have 3.33, and so on. Okay, so upcoming of numbers, you can see one and after another. Okay, so the various numbers occurring in a sequence are called its terms. So these individual numbers, we will be calling them as terms. We denote the terms of a sequence by A1 for first position, A2 for second position, A3 for third position, AN for nth position, and dot dot. This 3 dot represent that sequence might go further. Okay, etc. The subscripts denote the position, as I have already told you. Okay, clear? The subscripts denotes the position. Okay, now the nth term is also called the general term of the sequence. Okay, nth term called the general term of the sequence. Okay, now thus the terms of the sequence of persons and sisters mentioned above are, it is already given that A1 2, A2 4, A3 8, and the 10th generation A10, the number of persons and sister will be 1024. Okay, clear? Okay. Similarly, in the example of successive quotients, you will have the first term as 3, second term as 3.3, third term as 3.33, sixth term as 3.33333, etc. Okay. Now, a sequence containing finite number of terms, we will be calling it as a finite sequence. Okay, finite sequence. For example, the sequence of the ancestor is a finite sequence because it contains only 10 terms, a fixed number of terms. Okay. Infinite sequence means no fixed number of terms, means the terms are going further and further. Okay, clear? The sequence of successive quotient mentioned above is an example of an infinite sequence. As you can see here, these three dots shows us that our sequence is getting further and further. Okay, it never ends. The infinite sequence never ends, whereas the finite sequence ends. It is possible to express the rule which yields the various terms of a sequence in terms of algebraic formula. Consider, for instance, the sequence of even natural number. Okay, 2, 4, 6, 8, 10, and so on. The first position or the first term is 2, second is 4, third is 6, fourth is 8, and so on. Here you can express this sequence using some rule that you can answer that at 100th position what will be your term. Okay, or at 100th term or 100 what will be the number. Okay, so sometimes it is possible to express some kind of rule. For example, in this, that first term can be rewritten as 2 multiply 1, second can be rewritten as 2 multiply 2, third can be 2 multiply 3, fourth 2 multiply 4, and so on. Using the pattern, you can answer that the number or the term at 23, the number will be 2 multiply 23, means 46. At 24th position, you will have 2 multiply 24, means 48. Now you are able to answer that at 1000th position or 8000, what will be your number. Okay, clear? So it is it is very useful that if somehow we get the nth term expression, then you can answer a lot of things. Okay, so here what we use, an, the general term means 2 multiply n. Yes, where n is a natural number. Similarly, in the sequence of odd natural number, you can do what? That 1, 3, 5, 7, and so on. The nth formula given by an is equals to 2n minus 1, where n is a natural number. Okay, sometimes, okay, in some cases, an arrangement of numbers such as 1, 1, 2, 3, 5, 8 has no visible pattern, but the sequence is generated by recurrence relation given by like this. So first two terms will be 1 and the third term will be the sum of just previous terms or preceding two terms. Okay, general form, an is equals to an minus 1 plus an minus 2. Okay, clear? And this sequence we will be calling it as Fibonacci sequence. What? Fibonacci sequence. Okay, in the sequence of primes 2, 3, 5, 7, we have no nth formula. Okay, we can only be able to describe it verbally. Okay, no visual formula. So this shows that it is not necessary that you will always get a formula or specific pattern. Okay, so sometimes it is possible that you cannot get any formula. You can only describe by some verbal description. Okay, now let's talk about series. Series is just what? If you are having terms a1, a2, a3 till an given by a sequence, yes, then the sum of all the terms in the sequence, we will be calling it as a series. Okay. As you can easily see here. So first term plus two, second term plus third term till plus nth term plus and more terms if there are. Okay, so then such type of expression you will be calling it as a series. Okay, so the series is finite, can be finite or infinite according to the given sequence. Okay, finite or infinite. Okay, now series are often represented in compact form. What its compact form? The compact form we will be calling sigma notation using Greek letter this. Okay, this Greek letter. Okay, sigma. Okay, as means of indicating the summation. Okay, thus the series A1 plus A2 plus A3 till AN is abbreviated as summation k from 1 to n ak. This expression here is same as this expression but in compact form. Okay, remark, when the series is used, it refers to the indicated sum, not to the sum itself. For example, 1357 is a finite series with 4 terms, as you can see. Yes. When we use the phrase sum of a series means the number that results from adding the terms. The sum of the series is 16. Means if you add 1357, then you will get 16. Okay. I hope these things are clear to you. Let's see some example to understand better. Write the first 3 terms in each of the following sequences defined by the following. So an is equals to 2n plus 5 and an is equals to n minus 3 by 4. So you have to write first 3 terms. This means n, you have to use n is equals to 1, 2 and 3 only. 1, 2 and 3 for first, second and third term respectively. So a1 will be 2 multiply 1 plus 5 means 7. A2 will be 2 multiply 2 plus 5 means 4 plus 5 9. 2 multiply 3 plus 5 means 6 plus 5 11. Okay, so the required terms, the first 3 terms are 7 9 11. The same we will be doing here. N1 N2 and N3. N1 you will have minus 2 by 4 means minus half. N2 means minus 1 by 4. N3 means 0. Okay, clear? Very simple, very easy. Next example. What is the 20th term of the sequence whenever, okay, so whenever you are asked to find nth term or 20th, any nth term or general term, this means either the pattern follows, either the sequence follows some kind of pattern. You just have to crack the pattern or you just have to analyze it. Okay, clear? Okay, otherwise the nth form is already given to you. Okay, mostly it is not given to you. The sequence terms are given to you. You have to crack the pattern out of it and write out the general form. Okay, mostly in the mostly cases in exams this will happen. Okay, and that the sequence you will get is following some kind of pattern. So let's back to this example. So what is the 20th term of the sequence defined by? So here the nth term is already given to you. You just have to find the 20th term, means n, put n is equals to 20. So a20 will be 20 minus 1, 2 minus 20, 3 plus 20. This means 19 minus 18, 23. Multiply, you will get minus 7866. Okay. Next example. Let the sequence an be defined as follows. So you have defined your sequence in this way. Okay, recurrence way. So find first 5 terms and write corresponding series. So you have to just find first 5 terms. So A1 is already given to you. This means you have to find out the remaining 4 terms. This means for n is equals to 2, 3, 4, okay, and 5. So n2 means A1 plus 2. N2 means A1 plus 2 means 1 plus 2 means 3. A3 will be, the 2 will be added to the previous term, which is A2 plus 2 means 3 plus 2, 5. A4 will be 5 plus 2, 7. A5 will be 7 plus 2, 9. So the sequence will be, the first 5 terms will be 1, 3, 5, 7 and 9. And the corresponding series will be 1 plus 3 plus 5 plus 7 plus 9. Okay, clear? Okay. Now, exercise 8.1. Let's see the solution quickly. So write the first 5 terms of each of the sequences in exercise 1 to 6, whose nth terms are an is equals to n multiply n plus 2. Okay, so this means just you have to write how many first terms, just 5. So n is equals to 1, 2, 3, 4, 5. So quickly let's see. So a1 is equals to 1 multiply 1 plus 2 means 3. A2 will be 2 multiply 2 plus 2, 8. A3 will be 3 multiply 3 plus 2, 15. A4 will be 4 multiply 4 plus 2, 24. A5, 5 multiply 5 plus 2, 35. Okay, so therefore the required terms are 3, 8, 15, 24, 35. Now second, n divided by n plus 1. So n 1, 2, 3, 4, 5. For a1, 1 by 1 plus 1 half. A2 will be 2 by 3. A3 will be 3 by 4. A4 will be 4 by 5. A5 will be 5 by 6. Okay. Third, an is equals to 2 power n. This means a1 will be just 2. A2 will be 4. A3 will be 8. A4 will be 16. A5 will be 32. an is equals to 2n minus 3 by 6. This means a1 will be minus 1 by 6. A2 will be 1 by 6. A3 will be 3 by 6 or half. A4 will be 5 by 6. A5 will be 7 by 6. Okay. an is equals to minus 1 power n minus 1 multiply 5 power n plus 1. So substitute your n values. So a1 will be minus 1 power 0 multiply 5 power 2 means 25. A2 will be minus 1 power 1. 5 power 3 means minus 125. A3 will be minus 1 power 2 multiply 5 power 4. This means 625. A4 will be minus 1 power 3 multiply 5 power 5 means minus 3125. A5 will be minus 1 power 4 multiply 5 power 6. This means 15625. Okay, clear? Now sixth, an will be n multiply n square plus 5 by 4. So 1 multiply 1 square plus 5 by 4 means 6 by 4 means 3 by 2. A2 will be 2 multiply 2 square, okay, plus 5 by 4 means 2 multiply 9 by 4, 9 by 2. A3 will be 3 multiply 3 square plus 5 by 4 is equals to 3 multiply 14 by 4, 21 by 2. A4 will be just 21 and A5 will be just 75. Just use the pattern. Okay. Now find the indicated term in each of the sequences in exercise 7 to 10, whose nth term are. Okay. So nth term is given to you. You just have to find the given nth term. Here A17 you have to find and A24 you have to find. So for A17 put n is equals to 17. So 4 multiply 17 minus 3. Okay. This will be 68 minus 3 means 65. And for A24, put n is equals to 24. You will have 4 multiply 24 minus 3. So 96 minus 3 is equals to 93. Okay. An is equals to n square by 2n. Find A7. So put n is equals to 7. This means 7 square by 2 power 7. So 49 by 128. Okay. Now 9. An will be minus 1 power n minus 1 n cube. This means put n is equals to 9. This means minus 1 power 8, 9 power 3 means 9 power 3 means 7 to 9. Okay. Now 10th problem. An will be n multiply n minus 2 divided by n plus 3. So A20 you have to find. So put n is equals to 20. So 20 multiply 18 divided by 23. 20 multiply 18 divided by 23 means 360 by 23. Here you have to write the first 5 terms and then write the corresponding series. Okay, so A1 is already given to you. An is provided here, nth form. Okay, so A1 is 3. Now A2 will be 3 multiply A1 plus 2. 3 multiply A1 plus 2 means 3 multiply 3 plus 2 means 11. A3 will be 3 multiply A2 plus 2 means 3 multiply 11 plus 2 means 35. A4 will be 3 multiply A3 plus 2. A3 is 35. So 70, this will be what? 105 plus 2 means 107. Now A5 will be 3 multiply A4 plus 2. This means 3 multiply 107 plus 2. 3 multiply this will be what? 3 to 1. Okay, 3 to 1 plus 2 means 3 to 3. Okay, so hence the first 5 terms will be 3, 11, 35, 107, 3, 2, 3, and the corresponding series will be 3 plus 11 plus 35 plus 107 plus 3, 2, 3. Okay, and so on. For 12, A1 is given to you minus 1 and nth general form is given here. An is equals to an minus 1 divided by n. So A1 is already given. A2 will be A1 by 2. This means minus 1 by 2. A3 will be A2 divided by 3 means minus 1 by 6. A4 will be A3 by 4. So A3 is minus 1 by 6. Denominator will be multiplied with 4. This means 24. A5 will be A4 divided by 5. So here it must be 5. Okay. It must be 5. Clear? Sorry for that. Little typing error. Okay. So A5. So you will have A4 divided by 5. This means minus 124. The denominator 24 now getting multiplied with just 5. So you will get in denominator 120. Okay. Hence, these will be your first 5 terms and the corresponding series will be minus 1 plus minus half plus minus 1 by 6 plus 1 minus 1 by 24 plus minus 1 by 120 plus so on. Okay. Now 13. A1 and A2 term will be the same, equals to 2. An is given by An is equals to An minus 1 is minus 1. So the find first 5 terms. So first 5 terms will be A1 and A2 already given. A3 will be A2 minus 1. This means 2 minus 1 means 1. A4 will be A3 minus 1 means 1 minus 1 0. A5 will be A4 minus 1 means 0 minus 1 means minus 1. So your sequence will be 2, 2, 1, 0, minus 5. The first term will be these and the corresponding series will be 2 plus 1 plus 0 minus 1 and plus so on. Okay. Now 14th problem. The Fibonacci series. Okay. You have already seen what is Fibonacci sequence. So first two terms already defined as equals to 1. Okay, and the next terms follows this pattern. An is equals to an minus 1 plus an minus 2. So you have to find an plus 1 divided by an. Okay, you have to find this ratio. Okay, so for 1, 2, 3, 4 and 5. So quite simple. Just put n is equals to 1. You will have a2 by 1. So 1 ratio will be what? So in order to find the ratio, we'll first of all find the terms we will be using. Means a1, a2 already given, a3, a4, a5. These terms we will be finding first. So a3 will be what? A3, if you see here, a3 will be a2 plus a1. So a2 plus a1 means 2. A4 will be a3 plus a2 means 3. A5 will be a4 plus a2 means a4 plus a3 means 5. And a6 will be a5 plus a4 means 3 plus 5, 8. Okay, now the ratios. For n is equals to 1, an plus 1 by an will be what? A2 by a1 is equals to 1. For n is equals to 2, you will have a3 by a2 means 2 by 1 is equals to 2. For n is equals to 3, a4 by a3 is equals to 3 by 2. For n is equals to 4, a5 by a4, 5 by 3. And for n is equals to 5, a6 by a5 is equals to 8 by 5. Okay, clear? So this is it for now. Okay, I hope that you understood the concept of sequence and series. Now you have some idea, okay, about what do we mean by sequence, what do we mean by series, what do we mean by general term of a sequence. Okay, clear? Okay, so this is it for now. We will be back with the more from this chapter. So thank you. We will be back next time.